Things are going all right? Well, let's do one more example like what we talked about last time with, goodness gracious, sorry. We're given a polynomial here in factored form. And we're going to use the factored form for a lot of these things. But look at the polynomial, write down the important characteristics that we can determine from the polynomial, and then get a rough sketch. Okay? So the first part here is asking you the degree, right? Remember the degree again is what for a polynomial? The highest exponent that you see, right? Now in factored form, we have to do a little bit of work, not too much, but a little bit of work to get to that point, right? What do we need to do to get to what the degree of this particular polynomial is? If I needed the degree, I'd have to multiply all this out, right? So I would add the 4 and the 2, and what else? And the 1s as well, right? Because there's an understood 1 on each of these, right? Right. So again, if you were to multiply all of this out, you would multiply an x to the first times an x to the fourth times an x squared times an x, right? And when you multiply, what do you do with exponents? Add them, right? So they get to the degree, we just add these values. So what do you get in this case? 8. Good. Okay. Yep. So again, what we're doing to figure out the degree is basically, if you think about it in each piece, what's the highest degree here when you multiply it out? That would be 1. Highest degree here would be 4. Here would be 2. Here would be a 1. And you would multiply each of those together. So you'd add the exponents. That's the way it would work. Leading coefficient. Leading coefficient again is what? This is the definition of it. Good. It's the coefficient on that highest degree term. Exactly right. It's the coefficient on that x to the 8th in this case, right? All right. So if there's not anything to multiply out here, but what would be the coefficient on the x to the first term here? Well, just on the factor. Oh, just a 1 here would be a 1 on that x to the fourth if you multiplied it out, right? Here would be a 1 on the x squared. Here would be a 1. So what would we multiply the x to the 8th by when we were done? The 4. So what's your leading coefficient going to be in this case? A 4. Yep. Good. All right. So what this is telling, these two things together is telling us that your leading term is 4x to the 8th. That's what those two things together are telling you. If you don't have to do all the multiplication, right? We're just worried about what's on the leading piece, okay? If you were to go through and multiply all of this stuff out, your leading term would be 4x to the 8th. Now, why do we care about the leading term? What does that tell us about? Well, it's part C, right? The leading term tells us about the end behavior, okay? So we need two pieces of information to help us with the end behavior. Those two pieces are what? The degree and whether it's positive or negative, right? Those two pieces, right? It's x to the 8th. So do the tails point in the same direction or opposite directions? Same, right? It's an even degree, so they're both pointing either up or both down, right? Since the 4 is positive, which way is it? Up, right? Coefficient's positive, that degree is even. So that tells us that both are pointing up. So remember, we write our end behavior as x goes to infinity, f of x goes to something. And as x goes to negative infinity, f of x goes to something, right? Remember, as x goes to infinity means as you go to the right, something happens. As x goes to negative infinity means as you go to the left. Well, you just told me a second ago that both tails point up. So what are both of those answers then for as f of x goes to something? It both would be infinity. Good. Okay, so again, in words, as you go to the right, the graph goes up. As you go to the left, the graph goes up. That's what that would say in words. Okay. Questions about any of those three parts? Is that okay? Maybe. Yeah. Okay. All right. How do you, in general, how do you find a y-intercept? What do you do? Just in general, what do you do to find a y-intercept? Okay, so for a polynomial, it ends up being the constant term, right? But just in general, for any function, how do you find a y-intercept? X equals 0, right? Put in 0 for x and figure out the y, right? It's exactly what we're going to do here. We'll put in 0 for x and get out the y. I'll put it in each factor, so we'll have 4 times a positive 3, and then times a negative 2 to the 4th, a negative 5 squared, and a negative 8, right? That's what we're going to get when we put 0 in for all of those x's. If you're going to type this into your calculator all at once, make sure you're careful with your parentheses. If you put this into your calculator, you're going to get negative 16. But that's not what we want, right? If you don't put parentheses around the 2, or the negative 2, your calculator will do the exponent and then the negative, okay? So make sure you're careful with your parentheses when you're typing these in, okay? That 4th power applies to that negative. That squared also applies to that negative, okay? Just be careful when you're typing them in. Hopefully I gave people enough time to tell me what the answer is. Okay, how huge?
Negative 38,400.
Okay. Okay, negative 38,400. Okay. Sounds good to me. So calculators are for, right? So what point then, if I know that when I plug in 0, I get negative 38,400, what point's on your graph then? Good, yeah, 0 comma that, right? Intercepts are points, right? They're a point on the graph, so you should write them as ordered pairs. Okay. Bless you. All right, how do we find the x-intercepts now? What do we do? Just generally speaking, to find x-intercepts, how do you find those? Doesn't matter what the function is, how do you find x-intercepts? Yeah, that's exactly, for this one it's going to be, but just generally speaking, for any function that you have, what would we do? Yeah, you set it equal to 0, right? Yep, make the function equal to 0, good. So in this case, you'll set your 4 times x plus 3, and then x minus 2 to the 4th, x minus 5 squared, x minus 8 equals 0. So looking at each piece then, what makes the first one equal to 0? Negative 3, good. And the next one? 2, yep. And the next one? 5, and the next one? 8, right? Oops, I don't know why I put a parenthesis on the end there. All right, so those are, remember what we called those for a polynomial? Those are the zeros, or those are the roots. Again, though, intercepts are points. If we want to describe the intercepts, then we should write them as ordered pairs. Oops. So we should have the points negative 3, 0, 2, 0, 5, 0, 8, 0. So far, so good? Not too bad? Okay. Multiplicity of each 0. What do we look at for multiplicity? Yeah, the exponent on the factor that gave you that 0, right? So for my zeros here, we just said we're negative 3, 2, 5, and 8. your multiplicities then, we look at the exponent on the factor. For -3, it's going to be 1. For 2, it's going to be 4. For 5, it'll be 2. And for, yep, good. That okay? Yep. Okay. All right. So that's multiplicities. Now remember, the multiplicities tells you something about whether it crosses or not, right? And we'll get to that when we do that graph. What about where they flatten? What do we look at for flatten? We'll do crosses in a minute when we. Yeah, if it's greater than 1, yeah. So if it's greater than 1, it flattens, right? So it doesn't matter if it's even or odd. It's just if it's greater than 1, it flattens, right? So where does this one flatten?
2.
2 and 5. Good. Good. That okay? All right. So now we're ready for our rough sketch. And again, really rough, right? We're not looking for fancy. We're looking for rough. All right. We have x-intercepts at -3 and at, oops, that was fun. What were they again? 2, 5, and 8. Were those where they were? Did I remember that right?
Yeah.
Okay. And you had a y-intercept down at -38,400. Notice I'm not putting a y scale because that number is ridiculously large, right? Okay. All right, so we're gonna work our way left to right. We're gonna figure out where we need to start, either up high or down low. We're gonna figure out where we're gonna start and just work to every single point, right? We go left to right, we'll hit this point, then we'll hit this y-intercept, then we'll hit this point, this point, this point, and it should end where we're supposed to end. All right, when we're done, we've done everything correctly. End behavior tells us where to start. Should I start up in the left or down to the left? Up, right? I should start up here, and I'm going to come down to that point, right? Now this is where we're going to determine whether or not we're going to cross it or kiss it, right? That's even or odd multiplicity, right? What was the multiplicity for that one? 1. So does it cross it or kiss it? Crosses. When it's odd, it crosses, right? Did this one flatten? No. So we're going to go straight through it. Right? Then we're going to go down to that y-intercept. It probably doesn't go straight down there, but that's okay. This is rough, right? I said this is rough. Don't care about it other than rough, right? Come back up. We're going to go up to 2. What's the multiplicity for 2? 4. Does that mean it crosses it or kisses it? Kisses it, right? It's going to come up and bounce off, and notice that it flattened, right? If it kisses off of it, if it just touches it, it's always going to flatten there, right? Now I'll go to the next 0. What is the next one? What happens at the next one? It kisses it again, right? Just touches it, comes back up again, or off of it again. I guess I should say down. Go to your next 0. What happens there? Crosses. Does it flatten? No. So it just goes straight through. And did we end up in the right spot? Yeah, the end behavior is supposed to go up to the right, isn't it? Here we go. We're done. There's a rough sketch. It's not great, but that's it. That's the rough sketch. What questions do you have? Does this feel comfortable? Yeah. Okay. All right. Well, that's good news because you got a quiz on this on Moodle that'll be due tomorrow night. Okay. Literally one problem like this. Okay. Yes.
Why is the 8 not a 0 where it flattens?
What?
For the 0 with the graph flattens, why is 8?
Okay, so remember, when it flattens, that tells me that the multiplicity, it flattens anytime the multiplicity is greater than 1. So it has to be bigger than 1. So since the multiplicity is 1, it just goes straight through it. Okay. So problem just like this on Moodle for quiz. Now, for your sketch, you're going to need to take a picture of it to upload it to Moodle on the quiz. I want you to do that as a PDF. So there's instructions on how you can do that to change a picture to a PDF. I've got it right above the quiz link. Okay. If you've had 98 with either Professor Harshman or Dr. Stickles, did that for them. Same concept, all right? Literally, it's just that part. The rest are all just type in short answer, and there's one multiple choice. Okay? Giving you an hour and a half to do it once you start it. That did not take us an hour and a half, did it? Okay? The reason why I'm giving you an hour and a half is in case you have an issue with trying to get it converted over to a PDF for the last problem. Okay? For the rough sketch. I don't anticipate it will take you an hour and a half. I'm giving you an hour and a half time limit in case you have an issue with the file. Okay? Should be, literally, it's going to be just like this and the one we did at the end of class last time. So it won't be, it'll be a different function, obviously, but it'll be just like this. Okay? Yes?
Will it be factored, or will we have...
It'll be factored. No, it'll already be factored for you. Yeah. Yeah, literally just like this, just a different function. Yep. Yep. This okay? Yes.
Did you say that was the only question on the quiz?
Yes. Well, it's multiple parts, but yes, it's just the one. And as a matter of fact, I've written the same function in each part, so you don't have to keep scrolling up to go remember what the function is. Yeah. Mm-hmm.
Is this in class or online?
It's on Moodle.
Okay.
Yeah, it'll be on Moodle. It's due tomorrow night, 11:59.
Okay.
And I've already got an email set up to go out at noon tomorrow in case you forget. All right. Other questions on that at all?
No, not at all.
All right. Well, let's go on to some new stuff. All right. So, as we've seen, it's nice to have the polynomial in factored form to be able to read off where, for instance, it crosses the x-axis. Right? To be able to solve that equation where it's equal to 0. You've also talked about solving equations where you've had to factor things, right? So when you've got a quadratic, we can factor those relatively straightforwardly as long as they do factor. When you get third power cubic polynomials, it gets a little bit more difficult. You may have to do that factoring by grouping thing if it's going to factor. When the polynomials get higher than that, it gets harder to factor. Okay. So what we're going to talk about going forward for the next couple of sections is basically how do you factor polynomials that are bigger than, have degrees bigger than 3. Okay. Good news is that there's not a lot of things to try. So once you get to 5 or higher, there is no general method for doing it, unfortunately. Okay. So we're going to have some techniques that we're going to try, but no, generally speaking, there's not a lot you can do past a certain point. Before we talk about factoring again, we're going to talk about doing dividing, right? So remember that when you did factors in grade school, you were usually talking about factors of a number. It went in evenly, right? Had no remainder. And you could check if something did go into it evenly by doing kind of a long division idea. That's exactly what we're going to head here for polynomials. Is we're going to do polynomial long division. Okay. In some regards, it's a little bit easier to do polynomial long division than integer division. Okay. So let's go ahead and start talking about that. The first part we're going to talk about is what we're referred to as the division algorithm for polynomials. So the idea here is that I want to divide my f by some other polynomial p. think about when you divide something in grade school, when you do long division. For example, maybe you wanted to do 4 goes into 49, for lack of a better one. 4 would go into the 4 one time, right? And subtract and get zeros, and then you bring down your 9. That goes in twice, and you get a remainder of 1. And you're done, right? So a lot of times maybe you wrote that as 12 remainder 1. But another way that you could write that as 49 is what I divided into. 4 is what I divided by. If I do 4 times 12, I'm almost there. I would need to add my remainder. Right? That looks hopefully relatively familiar. Probably slept since grade school, but looks relatively familiar, right? Okay. This, writing it in this fashion, is what's known as the division algorithm. The 12 is the quotient, the 1 is the remainder. Okay? So we do that in a similar way for polynomials. We say that there exist unique polynomials we'll call them Q and R. And we'll talk about what we're going to write here in a second. But a unique part means you only get one answer, right? I don't want to do my division and come up with multiple answers, right? Over here, you went through this algorithm, you got done at a certain point, right? And you had one answer, didn't you? One quotient, one remainder, that was it, okay? Same idea. That's all the exist unique polynomials part means, okay? How did we write this over here again? Just looking at the numbers, this is what we divided into. This was what we were dividing by, correct? Okay. So over here, I want to divide my f of x by my p of x. So my f of x is going to be the thing that's on the left-hand side. We divided by 4. What did we call this thing that we're multiplying by the 4? The quotient. That's why we're using the letter Q here, right? So this will be p of x times q of x. What do we call this thing on the end? The remainder. So guess what? That's why we used an R here. Now to make sure that we have the unique part, notice over here, why didn't I stop at 9? Because 4 is going into 9, right? How did I know when I was done? When this number here was too small, right? When it didn't go in anymore? When the remainder was less than what we're dividing by, correct? Okay. Now notice it's a harder concept to talk about less than when we're talking about polynomials, but I can talk about their degrees, okay? So this remainder, when I talk about the remainder, either that remainder has to be 0 or the degree of the remainder, which you usually write as DEG, the degree of the remainder has to be strictly less than what you're dividing by. That's just the polynomial analog to your remainder has to be less than what you're dividing by. The less than part is just looking at the degree. Okay. If the remainder is 0, it just means it went in evenly. That's all the remainder being 0 would mean, just like it does for numbers. Okay. If it's not even, then I know, whoops, I forgot something. This is degree of p of x, sorry. Sorry about that. If it doesn't go in evenly, I know when I'm done, when my highest power on the remainder is less than the highest power on what I'm dividing by. Okay? So I know that sounds confusing. We're not going to write the definition down a lot. But look at this example. What are we dividing by? An x squared piece right here. The degree is 2. I know when I'm done, when I get to a remainder, it's either it went in evenly and I get a 0, or the degree is 1 or 0. I get a linear piece, an x piece, or just a number. And that's how I know when I'm done. Okay. All right, so how do we do this? Because that's what we're really interested in, is how do we do this division? And I'm going to set it up just like you do a long division in school, in grade school. I'm taking x squared plus 2x plus 7, and I'm dividing it into x cubed minus 3x squared minus x minus 5. That's how you would set up in grade school, right? Dividing that bottom polynomial into the top polynomial. Now, I know it looks ugly, right? Doesn't look great. But honestly, in a lot of respects, it's easier to do polynomial long division than integer long division. Because all I ever need to look at any step is I need to compare this to what I'm trying to go into for the highest degree term. Okay? Let's think about it this way. What do I need to multiply x squared by to get x cubed? X, yeah. I'll write it above, just keeping everything lined up. I'm going to write it above the x term. Okay. And that's exactly what we did over here for this division, isn't it? How many times does 4 go into 4? We did it one time, right? How did I know? Oh, let's look at the 9. 4 went into the 9 2 times. How did I get this 8? 4 times 2, right? So that's exactly what I'm going to do in the next step. I'm going to take this x and I'm going to multiply it by the entire thing over here. I'll get, let's see if I can get rid of that other one. X cubed plus 2x squared plus 7x. Right? Over here, when you got this 8, you did the 2 times the 4, right? Same concept. X times the whole thing. What did you do at the next step here when you had the 9 and the 8? What did we do? Subtract. Guess what we're going to do here? Subtract. Yeah, it's the same process. Okay? Now, I got to be careful. Be careful with your signs. I've got to subtract this whole thing, right? So this minus sign here has to distribute to each piece. Okay? So we'll have x cubed minus x cubed. That better go away. Your degree should be going down each time. Okay? Negative 3x squared minus 2x squared gives me negative 5x squared. Negative x minus 7x gives me negative 8x. Now notice when we did the division with the numbers here, I did the 4 first, and then I brought down the 9 for the next step, didn't I? Same concept here. Let's bring down the minus 5 here. Right? I didn't do anything with a minus 5 yet, correct? So I'm just bringing it down just like you do in number division, integer division. I'm not done yet because why? Let me highlight it here. That degree and that degree are the same still, right? I need a smaller degree, right? So I'm not done. Okay? So again, look at these two terms. My x squared and my negative 5x squared. What do you need to multiply x squared by to give you negative 5x squared? Negative 5. Okay. Take your negative 5 and multiply it through. Get negative 5x squared minus 10x minus 35. Now subtract again. Negative 5x squared minus a minus 5x squared gives you 0. It better, right? Negative 8x minus a minus 10x. What do you get? 2x. Good. Negative 5 minus a minus 35 plus 30. Pardon me. Again, big thing. Make sure that minus, you're distributing it to each term. Okay? It has to be subtracting that whole thing. Okay. Are we done? So what's the degree here? 2. What's the degree here?
1.
1. Is 1 smaller than 2?
Yes.
Yes. So we're done. Yeah. We're done. Cool. All right. So how do we write our final answer? Well, notice that this one is written. I can't erase the other part. It's fine. Notice that this is written as a fraction, right? So up here again, if you were thinking about taking your 49 and dividing it by 8, I could write that as what? 12 plus 1 over 8. It was not divided by 8. It was divided by 4. Sorry. It was 12, and then you do 12 plus a fourth. Usually if you wrote it as a mixed number, you wouldn't put the plus in there, right? But there's a plus there, correct? Okay. So since I have this written as a fraction, another way to write this is, pardon me, as kind of the whole number part, the x minus 5, the quotient part, and then plus the remainder over what you divided by. We're going to do more of these, but what questions do you have on this one? Again, this part that goes in front, if you're leaving it as a fraction here, this part that goes in front is your quotient, that part there. This is where your remainder is. Yes? Say it again.
So, define what factors in that, right?
You're looking at the leading term each time, so the x squared and the x cubed.
And then how many times that goes.
Yep, and how many times it goes in.
And then this is just its own separate thing.
And then you're subtracting, yep. Just like we did over here, right? The 4 went into the 4 one time. And then we did 4 times 1 is 4 and subtracted.
So I have to look for 5.
Say it again.
So I have to look for 5 because on the QB side, it's time to subtract.
Right, but it's always subtract, always subtract.
Even if it's.
Yeah, even if it's already a minus, it's always subtract, which is why we're doing minus a minus.
So the entire equation
Yeah, decreasing in the degree until it's smaller than what we started with. Yep, that's exactly right. That's when we know when we're done. Yep. Okay. Other questions before we do this next one? All right, well, let's do the next one here. So again, same setup. 2x cubed, 2x cubed minus 4x squared minus 2x minus 7 goes into 6x to the 5th minus 8x to the 4th. Is there an x cubed term on top? No. But let's put one in there so that we can keep things lined up nicely. There isn't one on top, so I'm going to write it as a 0x cubed. I just want to keep everything scaffolded nicely. Okay? Minus 10x squared. Is there an x term? Nope. So I'm going to put a plus 0x and then minus a 5. Only so that everything gets lined up nicely. Okay? I don't want it to look ugly. I don't want an x cubed to pop up later and I don't have something lined up underneath it. Or something to line it under. Let's try it again. Something to line it up underneath. I said those back. I said it backward. All right. Again, at each step, all we're looking at are the leading terms. What do you need to multiply 2x cubed by to get 6x to the 5th? What do you need to multiply 2 by to get 6? Let's do that first. 3. What do you need to multiply x cubed by to get x to the 5th? X squared. Yep, so we'll have a 3x squared that goes up here. Multiply the 2 by 3 to get 6, the x cubed by x squared to get x to the 5th. Dr. Olson doesn't like my voice carrying across the hall. Okay. What do I do with this 3x squared now? You gotta take that 3x squared and multiply it across that whole thing over here, right? Okay. So I get 6x to the 5th, and then what?
Negative 12x fourth.
Okay.
Minus 6x to the third. Minus 21x squared.
Okay. Yeah, take that 3x squared, again, that's 3x squared, and distribute it over that whole thing, right? Multiply by every single term. Notice this is why I said, look right here. Look at that part right here. That's why I put that 0x cubed in there, right? So it's lined up. Okay. And part of me just wants to play with the fact that there's a laser pointer on here, so I can do that, and then it goes away. Well, let's be honest, that's why I'm doing it. Okay. What do we do with those now? Subtract? Good. And again, your leading terms should cancel. That's the whole point here, right? We want the degree to go down each time. Okay? So 6x to the 5th minus 6x to the 5th gives you 0. What's the next one going to be?
4x to the fourth.
Good. Okay, so notice it's minus 8x to the 4th minus a minus, right? So you're really adding 12x to the 4th. The next one will be 6x cubed, a plus, and the next one will be 11x squared. Okay. Remember again, it's an easy place to make an error. Forgetting to distribute that minus all the way through. So if you want to, when you do this, go ahead and just change all your signs, and then you can add or subtract as necessary. Okay. It's an easy thing to mess up. It really is. Okay. So just be careful with it. Now again, let's bring down our other terms that we haven't used yet. We haven't used the x or the 5, right? So just bring them down. What's the next step?
2x.
Okay. So I'm looking at my 2x cubed and my 4x to the 4th, right? What do you need to multiply 2 by to get 4? 2. And then the x cubed, I multiply by an x to the 1st. Yep. So 2x will go up there. What do you do with the 2x again? Distribute it all the way through, right? So take that 2x here and all the way through. What do you get when you do that?
Negative 4x to the 4x to the fourth minus 8x to the third minus 4x squared minus 14x.
Okay. So yeah, do the 2x times each of those things, right? Everybody see that? And then again, we subtract down. What do you get when you subtract down?
Negative 4x to the fourth plus 8x to the third plus 4x squared plus 14x.
Okay, and so then when we simplify,
15x in second, 14.
good, yep.
Isn't the 6 supposed to be? Oh, it's minus the 6. Yep, so it's positive.
Okay. So we've got 6x cubed minus a minus 8x cubed, so we're adding. So we get the 14x cubed. 11x squared minus a minus 4x squared. So it's adding again. 0 minus a minus 14, so we're adding again. Everybody okay with that step? We're not quite done. We've got one more to go, right? Notice we've got an x cubed in both. So again, what do we need to multiply 2x cubed by to give us 14x cubed? 7. So we'll have a plus 7. So what do you get when you distribute the 7 through?
14x to the third minus 28x squared minus 14x minus 49.
Good news is this is the last step. What do you get now when you do your subtraction?
43x squared plus 28x plus 44.
Good. So again, distributing your minus through 15 plus 28 is what we end up with, right? To give the 43. 14 plus 14 to give you the 28. Negative 5 plus 49 to give you the 44. How do we know we're done? Why do we know that we're done?
Because this degree is less than the one we started with.
That's fantastic. Exactly right. This degree right here is 2. We started with over here with our quote, what we're dividing by, our divisor part as a degree 3. Okay. So we know we're done. So how can we rewrite then our fraction? How can we rewrite that 6x to the 5th minus 8x to the 4th minus 10x squared minus 5 over 2x cubed minus 4x squared minus 2x minus 7. How can we rewrite that? Yeah, okay. So the remainder, and then over to what you divided by. Exactly. Good. That's fantastic. That's exactly right. What questions do you have? It's tedious, but it is better than, I personally think it's better than working with a like big integer division, right? Because I only have to look at a single term. And it's not too bad to figure out what I need to multiply x cubed by to give me x to the 5th. I think it's better, personally. At least it's no worse. How about that? Can we agree on it's at least no worse than doing a long division of integers? Okay, good. I just wanted to see a nod. Okay, great. All right. Let's look at the next one. Work on that one for a couple of minutes. I know we don't have too much time left, but work on that one for a couple of minutes. Then we'll chat about it. So we only have a few minutes left. Let's go ahead and chat. I hear some chatter anyway. Does people's scaffold look like mine? Yeah? No? Where did you go wrong? Okay. All right, so let's just go through real quick. First thing we look at is what? Look at those two parts. Yep, look at the 3x to the third. What do you need to multiply x by to give you 3x to the third? 3x squared? Yeah? Yep. Multiply your 3x squared by, you get 3x cubed minus 12x squared. And we subtract. The 3x cubes cancel, but you have negative 16x squared minus a minus 12x squared. So that gives you minus 4x squared when you're done. Bring down your other terms. What do you need to multiply x by to give you negative 4x squared? Negative 4x. You should get negative 4x squared plus 16x. Subtract, again, 21 minus 16 gives you 5x. Bring down your minus 3. Finally, what do we need to multiply x by to give you 5x? 5. And then subtract, you should get 17. So finally then, if we take our fraction and divide it by x minus 4, well, how do you rewrite that?
3x squared minus 4x plus 17 over x minus 4.
Good. All right. Okay, so one thing I want you to notice about this, because we're gonna next time we're gonna talk about a shorter way to do this type of division. Notice that, pardon me, where did this 12 right here come from? Yeah, the 3 times the minus 4, right?
Yeah.
Okay, and then we added, didn't we? We took this coefficient and we added, right? Where did, pardon me, this 16 come from? Yeah, the negative 4 times the negative 4, right? And so on down the line, okay? So what we're going to do, and then we added it to the 21, didn't we? Okay? So what we're going to do next time is talk about how we can do this a little bit more shorthand and keep track of where these coefficients are coming from, okay? So we'll do that next time. Don't forget, Moodle quiz due tomorrow night at 11:59, okay? It's already at, well, it'll be active in 2 minutes. I had it turned on at 10:50. Okay? It'll be active in 2 minutes, so you can start it in 2 minutes. You have 90 minutes to finish. I do not anticipate it will take you longer than that. It won't take you the full 90 minutes at all. Okay? It's literally just like the problem we started class off with. Okay? I don't think the problem should take you more than like 10. I did the extra time to make sure you can get the file converted to a PDF and upload it into the quiz. Okay? That's what the extra time is for. Again, if you need the help with converting something to a PDF, there's instructions right above the quiz. I have a link to a document to tell you how to do that. Okay? Sound good? All right. We'll see you Friday, if not before.
Yes, I did. Actually.
Audrey, good luck at the track tournament or track meet. Yep.